session today, and hopefully I can interest you and I won't bore you. First of all, my presentation is not about the Institution of Mechanical Engineers. Suffice to say that the institution is the home of mechanical engineers. I'm going to share the experiences that I have had managing a company through the recession of 1980, 1990, 2000, and I will refer to the credit crunch of 2007, 2008. So, as I say, I'm not going to speak much about the institution, but I am going to talk about my position as managing director of a company who manufactured gearboxes for commercial vehicles. I joined the company in 1976 as managing director, and from 76 to 80 the company was very successful. The turnover increased year on year, the profitability increased, I was enjoying myself. And then in 1980 there was a major recession. I wasn't ready for it. It took me by storm. My sales reduced by some 40%. I reduced the overheads, but I was determined not to reduce them to the point that it would destroy the infrastructure of the company. And after doing so, I was still making losses, and I had the group chairman on my back saying that if I didn't come up with a convincing business plan very shortly, they would have to consider the future viability of the company. So I had to find alternative products. I had to bring more products into the company. I said the company had been in existence over 100 years, so I had a responsibility. So the products that were manufactured, the expertise of the company was making gearboxes and designing gearboxes, and they were very good at that. But they had no experience in any other industry. So it was necessary to find gearbox products in other industries that was buoyant and that we could sell to, and that was no easy task. These are the products that were manufactured at the time. They are gearboxes. The first ones are ancillary gearboxes that are supplied to the motor industry, quite often used to transfer the drive from the gearbox to the centre of the vehicle for the prop shaft. The power takeoffs are for lots of different applications, and we have power takeoffs for virtually every vehicle combination in the UK. Winches for wreckers vehicles, they're quite obvious for pulling vehicles out of ditches. They're used in the military for pulling tanks out of ditches and that sort of thing. Fuel pumps for aircraft refueling, for pumping oil, that sort of thing, and hydraulic piston pumps. So that was the general range of products at the time. The fuel pumps were not of our own design. They were from a sister company that we manufactured, and they were feeling the pinch of the recession, so they took them back. The winch products almost dried up completely because of the recession. The gearbox and piston pump sales, as I've said, they're reduced by some 50%, and the company needed new products to survive. So I had to look at other industries and try to find an industry that was buying gearboxes and to be able to produce them and sell to them. No easy task. These are the major industries that I looked at, 5 of them, because all of them use gearboxes. And we very soon found that the lift industry was extremely busy in spite of the recession. And they were busy doing a major refurbishment exercise on the lifts that had been installed in high-rise buildings during the 1950s and 60s. And as I say, the industry were extremely busy. But I couldn't just accept that and incur money and try to design a gearbox and supply to them. So this is just confirmation of what I've said. So I decided to visit 6 lift companies, and I visited the managing director of each of them, and I think those are the companies. The first company I visited was Stella. Most of you will have heard of Stella lifts. I met the managing director, and I can still remember his name. It was Malcolm Colburn. And the first thing he did was confirm the buoyancy in the industry. He said that they are snowed under with work, and he said that this refurbishment exercise was likely to continue for about 10 to 15 years because there were thousands of lifts requiring replacement now and a progression over the next 10 to 15 years. So that was a good sign. So I then asked him, where do you get your gearboxes from? And he said there are mainly 2 Italian companies who we buy them from. And I said, are you happy with them? Are they reliable? He said, they're very good gearboxes, they are reliable, the quality is good, they don't really have problems with them. So I said, do they satisfy all of the requirements, everything that you would like? And he said, well, not exactly. He said, there used to be companies who supplied gearboxes that really satisfied all of our requirements, but they're no longer available. So I said to him, okay, can you go through with me and explain exactly what the differences are? And we spent the next 2 hours going through these differences. And at the end of the 2 hours, I said to him, if we were to produce a prototype and we could demonstrate to you that it had been tested thoroughly, it met all the standards, etc., and it gave you all the things that you don't have in the other gearboxes, would you give me an order for 2 prototypes? And he said that he would. So I went to the next company and I had a similar discussion, and Coney, Marriott and Scott also agreed to give me a prototype. They all confirmed the buoyancy of the industry, and at the end of when I'd completed this exercise, I came back to the company with reams of notes, and I put together a specification that incorporated as many of those features as possible. I then had no design engineers to design it, so I had to do it myself. My design engineers were working on the remaining work in the motor industry, and I certainly couldn't let that go. So I designed it myself. I subcontracted the various component parts of the gearbox, and then we built 2 prototypes. I then hired a lift tower, a lift test tower. It was a 6-floor tower, and it was set up for an 8-person passenger lift, which was the one that we were designing the gearbox for. We tested the unit for 6 days a week, probably 10 hours a day, and we did that for 4 weeks. And I wanted to make absolutely certain that the prototypes that we offered to the companies would not fail, that they would be right in every respect. At the end of 4 weeks, I was convinced that we had satisfactory prototypes to demonstrate. So I had a tow bar fitted to the back of my car. We put one of these units, and these are very big units, with a control panel, and incidentally it was a mechanical control panel in those days. And I took it to Stella Lifts, the first company, and they were absolutely amazed that I'd done what I had said I would. We coupled it up to a 3-phase supply, and I was able to demonstrate it, obviously not under load, but I had all the test results from the lift tower, test tower. Our company were experienced gearbox manufacturers, so we knew all the standards that we had to maintain and work to, and I demonstrated it to them, and he gave me an order for 2 prototypes. I went to the other 5 companies with exactly the same procedure, and I got orders from each of them. So I came back from that trip with orders for something like £60,000, which was rather good for the company. The 12 prototypes were delivered to the companies, and they installed them into installations. And this is just an example to show you a lift drive unit and in an installation. And they gave our company full access to be able to monitor their performance. And we did that very continuously over a 3-month period. In fact, some of the people that I had made redundant, I re-employed to go around on a daily basis monitoring these gearboxes. And again, I'm very pleased to say they were successful. And after the 3-month period, we started to obtain quantity orders, small quantities from these companies. And because we had a gearbox that satisfied the requirements of the industry, we started to receive orders from many other lift companies. And suffice to say, in the Greater London region, there were over 50 lift companies, which surprised me, but it was extremely good because I could go to London and visit lots of companies in a short period of time. So we started supplying gearboxes for 8-person passenger lifts to the majority of the lift industry. Well, then, of course, it was necessary to develop a range of gearboxes. So we had to develop gearboxes for all of these 5 different types of lifts that you see there, because a lot of the companies produced all of those types of lifts, and if we didn't supply all of them, we could only capture a proportion of the business. So we developed gearboxes for all of those types of lifts, and again, we were very successful in doing so. The company was back into profit in 1981, which I was delighted to see, and virtually all of those people redundant I re-employed, and I'm very proud to be able to say that. And actually, some of them did very, very well out of it, because they came back after about 9 months or 12 months. So they got a good redundancy pay, and then they had the job back. So they did very well, and I was quite pleased. So we expanded the company quite considerably over the 1990s, and it was a very, very successful exercise. The large companies such as Otis and Express, they manufactured their own gearboxes, but I was quite determined to be able to supply to those companies. So eventually I convinced the managing director of Express Lifts that we were better equipped to produce special gearboxes when they had a special requirement, which they did from time to time. And eventually he agreed to do so. So every time they got a special, we got an order for the gearbox, which was very good news. But the one that I had the most difficulty with was Otis, the big O. Otis manufactured their own gearboxes, and they were very adamant they would never buy from anyone else. And their design office was on Clapham Road in London. So every time I went to London, I reserved 2 hours to go on Clapham Road to the design office of Otis. And I went there so often that I got to know all of the people. They allowed me to go into the design office without signing in. And as I went in, the guys would jeer at me and say, "We'll never buy from you." And then we'd sit down and have a coffee and talk about what they were doing. And we had a very good rapport, actually. And one day, they had a problem with a lift in Reading. And the technical director rang me and asked if I could resolve it for them. So I got over to Reading fairly quickly and identified the problem. Fortunately, we had a gearbox on the shelf that was right for that application. So the following day, I got 2 guys down to Reading with this gearbox, installed it, and got them back in service. As a result of that, they put our company on the specification for that type of lift, so that every time they received lifts of that type, we got the order for the gearbox. So I could then say we supplied gearboxes by 1985 to the entire lift industry. And of course, it saved the business. So during the selling process, I can't emphasize enough these points, that the product had to be presented properly and professionally to the companies, because most of the companies were new companies to our company, and therefore we had to convince them that we were capable of producing gearboxes that were satisfactory for the job and give them all the results. So that was an important thing. So we had to make different types of presentations to different types of companies. We had to provide pictorial and graphical information. We had brochures and leaflets and things to do that. And obviously, as any professional engineer worth his or her salt will always want to know what their competitors are doing. So we examined all of our competitors' products. I had a locked room with one of each, so that we could make sure that what we were doing was certainly as good as, if not better, than they were doing. So these are, of course, the requirements of a professional engineer, and they are the exact requirements of the design challenge, which is a challenge that I run for the institution with undergraduate engineers. And I'll come on to that shortly. So during the 1990s, we started to, in 1990, the lift business enabled our company to trade through the recession without any, I think the sales went down maybe 5-10%, nothing to really get too upset about, and we didn't make a loss. We made a small profit, during that recession. And it was really the lift business that helped us to do that, because we had products in an industry or in part of an industry that was still buoyant. But it wasn't sufficient, because when this refurbishment exercise ended, and it was due to end within the next few years, then we would be back to square one. So during the 90s, we started to introduce gearboxes for other products. And you'll recognise one of the products at the bottom of the list. Our company started to manufacture the different products. And I'll not go into these in a lot of detail, because this is the subject of another presentation. But there was a lot of work and a very interesting exercise how we managed to get this business. I wanted to get business that was not affected by recessions to the same extent. And if you look on this list, the gearboxes for the earth-moving vehicles, they are government contracts, quite often 3-4 year contracts. So if those contracts have been placed and the recession appears, then the industry is still buoyant because of the contracts that they already have. The bottom one you'll be interested in, we manufactured the complete drivetrain for the 8-wheel troop carriers. That is the link gearboxes, differentials, the axles, etc. And that's very lucrative business, because again, it's not affected by recessions, because it's long-term business, and it is, if a recession appears, the business continues because the orders have been placed. So that is what we did during the 90s. And that meant that in the recession of 2000, with all that range of products, we were able to ride through it without having to make anybody redundant, with probably a slight drop in profit, but not nothing too significant. Now, I mentioned the design challenge. The design challenge has got 4 main elements to it. First of all, we give a detailed specification to teams of undergraduates, first-year undergraduates. And from that specification, they've got to come up with a design solution. They've got to make it, they've got to test it, and they have to compete internally. And the 2 teams that normally win the internal competition go to regional competition run by the institution at one of the universities. And the competitors have got to, obviously they've brought their design, their product with them, ready to test. They've got to do a presentation of their design to show the technical features, etc., and the engineering science that underpins it. They've got to do a poster, which is the brochure, the pictures of what they are doing, and they've got to do a peer review where they examine the designs of all the other teams and rate them accordingly. And they have to project manage the project from start to finish. And it's a very, very interesting competition. In fact, the competition in the Northwest region this year is on the 7th of March at the University of Manchester. Anybody who wanted to come, you can certainly come along to it. It's a very interesting competition, and it starts at 10:30 in the morning on the 7th of March. So now, the application of the design challenge. I referred to transfer boxes. These are some of them. The one at the bottom left is actually a 4-wheel drive gearbox. And these products are normally at the request of the motor manufacturer, who would require a gearbox to transfer the drive to do something, 4-wheel drive to drive something, and then our company would design it and present the design to the motor manufacturer, and then produce a prototype, and we'd have to do presentations and so on. In other words, all the things of the design challenge. I referred to the power takeoffs. Those were products of our own company, but we had to make sure that they fitted to the gearboxes correctly, and they were available for all the different types of ancillary equipment that can be used on the commercial vehicle. So, but once again, we had to go through the same process of the design challenge. The next one, these are driveline gearboxes that fit into the chassis of a vehicle. They take the drive from the rear of the gearbox, and then a drive that goes to the rear axle, but you can then transfer the drive to drive a vacuum pump or whatever. And the great thing about these gearboxes are that you've got the full range of gears on the vehicle gearbox, the forward gears and reverse. And if it's designed correctly, you can actually transmit the full engine torque. So it's a very versatile gearbox, and providing it will fit, you can put them on any vehicle, and there are lots of different sizes of them. And then of course the lift gearboxes, I've explained how we introduce the lift gearboxes and how they fit in with the design challenge. So lessons learned. I think getting accurate information is obviously important, because in the lift business, if I hadn't got the accurate information for the specification, then it wouldn't have worked. Thoroughly testing the prototypes. If those prototypes had failed, we would have been dead in the water. There'd have been no way we could have proceeded. So I made sure they were tested, double tested, triple tested, to make absolutely certain they were right before I offered them to the companies. Differentiation. I mentioned before that the companies had said that the gearboxes they used to buy were different. I'll just give you 3 examples. The first one was that they wanted to have plain bearings on the output shaft. They said that the gearboxes that they are buying have got taper roller bearings, which are very quiet, very smooth, but they are not as good as gearboxes with plain bronze bearings, because the load capacity and the vibration is much less, and therefore that's what they would like. Secondly, they said that the gearboxes they used to get could not start from the output shaft. In other words, no matter how much load you put on the output shaft, the gearbox wouldn't start because of the wedge action of a worm reduction gear set. The gearboxes they were buying had a lower ratio worm reduction gear set and then a train of helical gears, and hence you could start it from the output shaft. The advantage of their design was that you could have a smaller motor, it didn't need as much power, but the industry didn't like it, because having this facility of being able to sustain the load of the output shaft is an additional safety feature, which is important. It also helps with deceleration. It makes the deceleration much smoother, because the worm set is also creating that. And if you have a single ratio worm reduction gear and it is over 43:1, it's self-sustaining. In other words, if you try to start it from the output shaft, there's a wedge action between the helical teeth, and it will not start. No matter how much load you put on it, it won't start. And that's what they wanted. And the third thing was they wanted an external brake that is adjustable. The gearboxes they were buying had an internal brake that wasn't adjustable. So we introduced those 3 features together with quite a number of others. And that was the differentiation that enabled us to succeed. I've said about the presenting the products before, and obviously you need to develop a good relationship with your customers. That's very important. And then introducing products into another industry, I think I've demonstrated that it's possible to do so, and to do it successfully. But you've got to make sure what you're doing is right, and you must not make mistakes. The product you produce has got to do what it's supposed to do, and do it continuously. Because I was quite aware if we got it wrong, we would not survive. And my back was against the wall in 1980, because had they failed, our company would have failed. I'd have lost my job. The whole thing would have been would have gone to the wall, and I couldn't allow that to happen. So obviously, you can steal the marks on existing suppliers, as I've demonstrated, with differentiated products, and I've explained the differentiation that I have that we introduced. So in conclusion, it's good to concentrate on core products. You will hear lots of the large organisations say that companies should concentrate on the core products and become very skillful at producing them. And that I agree with. But it's also beneficial to have diversity using the same technology. In other words, in our case, gearboxes. Doesn't matter whether it's for the lift industry, the motor industry, the whatever industry, they're gearboxes, and therefore you use the same technology to design and produce them. Recession cycles are not the same in all industries, and I've referred to that. There are parts of the motor industry, like the earth-moving industry, where the recession is not the same as the recession across the rest of the country. And of course the military, that's another area that I mentioned. So that's an important feature. And by having the right balance, it is possible to trade successfully through a recession, as I hope I have demonstrated to you. Thank you.